So we're going to start out today by talking about another intermediate operation in Java streams called mapMulti. And we'll talk about this operation. This is a stateless run-to-completion operation that can do various things. It can replace map filter combinations. It can also, in some ways, replace flatMap. We'll talk about that as well. And we'll also talk about how it can work around the limitations with flatMap when used with parallel streams. We'll spend more time on that in upcoming discussions. This method was available as of the Java 16 API. So it was not part of Java 8, it was not part of Java 9, et cetera, but it came available in Java 16. So let's talk about this operation. mapMulti returns a stream that consists of the results of replacing each element of the input stream with potentially multiple elements, specifically 0 or more elements. So it might actually be no elements. It could be 0 or more. So it basically can be used to do combinations of map and filter, as well as flatMap. Those are the semantics that it can provide. The output of the output stream that comes from mapMulti may have a different number of elements from the input stream. So it turns out it can have the same number, it can have less, it can have greater, and we'll talk about those things. That is very, very similar to flatMap. mapMulti can also filter and or transform the type of the elements that it processes. So it really is this kind of interesting conglomeration of a whole bunch of other things all packed into one method. And we'll talk about why they do that in just a minute. Here's a simple example that is part of the Simple Search Gang implementation. I updated this just over the weekend. And so you'll notice, if you recall, there's no reason you should have to recall this, but the original example we used for Simple Search Stream had an array of words, or basically a list of words to find, or an array of words to find. Turned that into a stream, then it did map, then it did filter, then it did toList. By using mapMulti, we can get around having to have calls to map followed by filter and just have a mapMulti call. And here's what the implementation looks like. This is called search for word if. And what it'll do is it'll go and search for the word, and if what comes back is not empty, it will then accept that result, and that will be what is returned into the stream. If, in contrast, the result is empty, then the accept call will be skipped, and so there will be nothing emitted in the stream. So you can kind of see how it's combining map and filter into the same method, the same behavior. So that eliminates the need for a separate filter intermediate operation, which can help make things a little faster, although there's better reasons for why you might consider using mapMulti. So let's briefly talk about some ways it can overcome limitations with flatMap. I will spend more time on this, and I'll show you a really cool example that I cooked up recently that demonstrates this, but this is just to give you a teaser. So if you may recall, flatMap got some problems when used in parallel streams, and that's because, for reasons that somewhat escape me, the implementation of flatMap always runs sequentially for inner streams. And that's just the way it works. If you read about this at Stack Overflow, it explains this, and it points to the code, and so on and so forth. So as a consequence, if you use flatMap with an inner parallel stream, so you can see here we have an outer parallel stream that generates a bunch of values, and then we have an inner parallel stream that also tries to generate a bunch of values. This will always run sequentially, even though we make it parallel, which seems a little counterintuitive, I agree, and it is counterintuitive. And we'll look at that in more detail. Something else we'll look at in more detail is you can replace the use of flatMap with mapMulti, and you can get the inner parallel streams to run in parallel as intended. I won't go through this example in detail right now. We'll look at it in more detail here shortly. So when should you apply mapMulti? Well, if you have a variable number of output elements. So remember, by definition, map always generates the same number of output elements as there are input elements, unless an exception is thrown. So assuming an exception is not thrown, same number of input elements, same number of output elements. But if you want to have more elements, then mapMulti is more suitable than map, in much the same way that flatMap is more suitable. Another nice thing you can do is you can avoid nulls and filters. So if you transform something that results in null values or empty values or whatnot, mapMulti can simply get rid of these values without you having to put a separate call to filter after the return from map or after the output stream comes out from map. So that's another benefit, another reason to use it. Probably a even better reason to use it is to avoid intermediate collections. So with flatMap, you often need to create intermediate collections when you generate multiple output elements for a single input element. And you don't have to do that with mapMulti. You can emit elements directly into the resulting stream without having to turn things into collections and back to streams and so on, which is really cool. And I'm going to probably go back and retrofit some of my other examples to take advantage of this feature. And then another motivation is to avoid complex transformations. If you have some processing that doesn't really fit nicely into map, filter, and/or flatMap, or you have to chain these things together in some convoluted way, then mapMulti is more flexible because you can get things done directly. And another thing you can do if you choose, you don't have to do this, but one thing you can do is you can also mix somewhat imperative-style programming in the implementation of mapMulti's behavior. And we'll look at how it works when we take a look at the example here in a second. So that's a quick overview of the Java Stream's intermediate operation mapMulti.